Hello, and welcome to this lesson on the physical properties of hydrocarbons. In today's lesson, we will investigate how boiling point, viscosity, and flammability, and other properties are influenced by the size and molecular structure of hydrocarbon molecules. So far, we've introduced hydrocarbons and the origins of crude oil, looking briefly at some of the key distinctions and aspects. Building on this foundation, today's lesson will deepen our understanding of hydrocarbons generally by examining how their physical characteristics are altered by molecular size and structure. This will advance our broader chemical knowledge and help us appreciate the practical applications of these organic compounds. Let's start with boiling points. Boiling point is the temperature at which a substance changes from a liquid to a gas. In the case of hydrocarbons like alkanes, the boiling point depends on the size of the molecules. Generally, as the size of hydrocarbon molecules increases, the boiling point also increases. This is because larger molecules have a greater surface area, which means there is more contact between the molecules. As a result, the intermolecular forces become stronger in larger molecules. For example, a small hydrocarbon molecule like methane has a low boiling point of about 161 degrees Celsius. Compare this to octane, a much larger hydrocarbon. This has a boiling point around 125 degrees Celsius. The larger octane molecules have stronger intermolecular forces which need more energy to be broken. Hence, turning it from a liquid to a gas requires a higher temperature. Next, let's discuss viscosity. Viscosity is a measure of a fluid's resistance to flow. Imagine pouring water, a low viscosity liquid, and then pouring syrup, a high viscosity liquid. Water flows easily and quickly, while syrup flows slowly and with difficulty. Using the jargon, syrup has a higher viscosity, while water has low viscosity. In hydrocarbons like alkanes, viscosity increases as the size of the molecule increases. This is because larger molecules have a more complex structure and can become entangled with each other. Think of small molecules like small pieces of string. They can move past each other easily. But larger molecules are more like long ropes that can get tangled, making it harder for them to slide past one another. Additionally, larger molecules have a greater surface area, which allows more intermolecular forces to act between them. The stronger these forces, the more difficult it becomes for the molecules to move, which slows down the flow of the liquid. As a result, smaller hydrocarbons like pentane are less viscous and flow more easily, almost like water. In contrast, larger hydrocarbons like hexadecane are more viscous, meaning they are thicker and flow more slowly like oil or syrup. So, the larger the hydrocarbon molecule, the thicker and slower it flows. Now, let's tackle flammability. Flammability refers to how easily a substance can ignite and burn. Smaller hydrocarbons have shorter chains, which means the bonds between the carbon and hydrogen atoms are easier to break. This requires less activation energy to start a combustion reaction, making it easier for them to ignite. Additionally, smaller hydrocarbons like methane, propane, and butane are more volatile. This means they evaporate quickly at room temperature, turning into gas. Hydrocarbons burn in the gas phase, so when a hydrocarbon is highly volatile, it produces more vapor. A higher concentration of vapor in the air makes the substance easier to ignite because there is more fuel available to burn. In addition to boiling point, viscosity, and flammability, molecular size also influences other physical properties. Let's quickly run through some of these. Firstly, larger hydrocarbon molecules typically have higher densities due to their greater mass. Secondly, hydrocarbons generally do not mix well with water, but smaller hydrocarbons are slightly more soluble in water than larger ones. Smaller hydrocarbons have a lower surface area compared to larger molecules, meaning there are fewer intermolecular forces between them and other hydrocarbon molecules. This allows water molecules to interact more easily with smaller hydrocarbon molecules, enhancing their solubility. Finally, like boiling point, the melting point of hydrocarbons generally increases with molecular size due to stronger intermolecular forces. By understanding these key concepts, we can better grasp why different hydrocarbons are chosen for specific applications. For example, small, highly flammable hydrocarbons like propane are ideal for quick, intensive energy release, while larger, more viscous hydrocarbons are suitable for applications requiring slower energy release and lubrication. In today's lesson, we investigated how the physical properties of hydrocarbons, such as boiling point, viscosity, and flammability, are influenced by the size and molecular structure of hydrocarbon molecules. We also explored density, solubility, and melting point. Understanding these properties helps us appreciate why different hydrocarbons are used in specific applications, such as using propane for quick energy release and kerosene for controlled burning in jet fuel. This knowledge underscores the practical significance of hydrocarbons in everyday life and various industries. Watch the rest of the GCSE chemistry course at Sophos Education.